All right, I'm going to do the Unit 2 review here. I'm just going to get right into it. Looks like we're going to start with question 1 is Haley has some money to invest, pays 3.25% APR, compounded monthly. So question is, how much is it worth 15 years later? So the original equation A of t is a sub 0 times 1 plus r over n to the n times t. With that said, we're going to plug in what we know. So we want to find the final amount. So a sub t is still the unknown. We start with 2750. The rate 3.25 has to be written as a decimal. Our n is that how many times is it compounded per year. So that monthly means we compound 12 times. N again up here, so that's 12, and t is 15 years. At this point, we just get to plug and chug. We find that A of 15 years of just sitting in the bank, they have 4,474.71 cents. Okay, next, smaller again. Now what we have, see if I can get my arrows. There we go. Kari wants newborn child to have a nest egg of 20,000. She's starting with 10,000. Compounded monthly at 3.3%. It's kind of a two-part question. How long will it take to reach 20,000? And the second part is, based on how long it takes, will she make the goal of having 20,000 by the time her child leaves for college? So if we do the same thing, we say, oh, there we go. There we go. A of, how long will it take? So A of t, you know what, I'm just going to do this. I'm going to start this over. I'm going to fill in what we know just so I can save some space. What we know is that our A of t, our final amount, is 20,000. Our initial amount is 10,000. Our rate is 3.3%. Monthly, so that's 12. And then n times t is where we get our variable. T is, we want to know how long is it going to take for this to reach 20,000. So a little bit of simplification we can do. We can say divide both sides by 10,000. So we get 2 is equal to, if you do 1 plus this fraction, what that equals is 1.00275. I'm going to raise that to the 12t exponent. So at this point, we can take the log of both sides, right? Algebraically, we have to do what we do to one side, we have to do to the other. And in order to get an exponent back down out of the exponent position, if we take log of both sides, we can do that. So log of 2 is log of this number and the rules of logarithms say if we have an exponent on a logarithmed number, we can actually rewrite it so that the exponent comes out front. So if I rewrite it, it just looks like log of 2. By the way, if there's no base number written, it's assumed to be 10. But we've already established that a while back. So now I get to write 12t out front. So I can write 12t. I'll even put it in parentheses, times log of 1.00275. Perfect. Now we can divide both sides by log of 1.00275. Perfectly legal move. So we get this is equal to 12t. That number, well, you know what I'm going to do? I'm just going to erase that and just, I'm not going to do this last step. Last step is, so you'd simplify. You take log 2, and you get some decimal number. Divide that by log of 1.00275, get another number. So this fraction here, divide by 12, t equals 21.03 years. Okay, now this is part 1 of the question. How long will it take her to reach her goal? It'll take 21 years. So as soon as baby's born, put money in the bank. 21 years later, you now have the 20,000 you wanted. The second part of this question asks, will she make the goal by the time her child leaves for college? Now, I'm going to go out on a limb and assume that this child is going to go through the traditional education system and go to college around the time they are turning about 18 or 19. So at 21 years, I don't know any freshmen in college who are 21 unless they took a couple of years, skip years. So I'm going to say, does she reach the goal before she leaves for college? No. Let's see. You know, these are the exponential growth and decay. I'm going to pause this video, just call it part 1. So yeah, I'm going to make part 2. We'll do questions 3, 4, and 5, and however many else we can do.